Hi, myself Lakshmi Bhadrapur and I am from BSc 5th SEM and I am currently studying in Sri Siddheshwar Government Postgrad College and PG Study Center, Nargund. Today I am here to deliver my seminar on topic of problems on transport number and Kohlrausch Law and its application. Let us see some problems on transport number. First problem. A decinormal solution of silver nitrate was electrolyzed between platinum electrodes. After passing small current for 2 hours, a pollen concentration of 0.000524 gram equivalent occurred in the anodic solution. The mass of copper deposited in copper colorimeter placed in series was found to be 0.03879 gram. Calculate the transport number of silver nitrate. Equivalent mass of copper 31.8. Here the given are Paul of concentration around anode is 0.000524 gram equivalent and mass of copper deposited in copper colorimeter is 0.03879 gram. Gram of copper deposit is equal to 0.03879 divided by 81.8 is equal to 0.0012190. Now transport number of silver nitrate. Gram equivalent of silver ion at anode divided by gram equivalent of copper deposited at cathode. 0.000524 divided by 0.001219 is equal to 0.4203. Transport number of NO3 minus is equal to 1 minus T plus is equal to 1 minus 0.4203, 0.5797. Here is the next problem. A solution containing 2.84% of copper sulfate was electrolyzed using platinum cathode and copper anode. After electrolysis, the cathode solution was found to weigh 54.700 gram and to contain 0.409 gram of copper. The increase in the weight of cathode was 0.408 gram. Calculate the transport number of copper plus 2 and sulfate ions. 54 gram of cathode solution after electrolytes is equal to 0.409 gram of copper plus 2. 100 gram of cathode solution before electrolysis contains 2.84 grams of Cu plus 2. 54.7 gram of cathode solution before electrolysis contains 2.84 into 54.70 divided by 100 of copper sulfate. Equivalent weight of copper is 31.8. Equivalent weight of copper sulfate is 79.8 gram equivalent. 54.70 gram of cathode solution before electrolysis contain 2.84 into 54.70 divided by 100 into 31.8 divided by 79.8 of copper plus 2 is equal to 0.622 gram of copper plus 2. Loss in weight is equal to y minus x. Y is 0.6222 minus x is 0.409. Then it equals to 0.2132 gram of copper plus 2. Total decomposition is 0.408 gram. Transport number of sulfate is equal to loss of ion in cathodic composition divided by total electrolytic decomposition is equal to 0.2132 divided by 0.408 is equal to 0.5225. The transport number of Cu plus 2 is 1 minus 0.5225 is equal to 0.4775. Here is our third problem. A dilute solution of CuSO4 was electrolyzed using platinum electrodes. The amount of Cu per unit weight of the anodic solution was found to be 0.6350 gram and 0.6236 gram before electrolysis respectively. The weight of the silver deposited in silver colorimeter placed in series was found to be 0.1351 gram. Calculate the number of transport number of Cu plus 2 and SO4 2 minus ions. Solution. Weight of copper in anodic after electrolysis is 0.6236. Weight of copper before electrolysis is 0.6350. Loss of amount of copper in anodic solution is 0.6350 minus 0.6236 is equal to 0.00114 gram. Equivalent of copper deposited is equal to 0.1351 into 31.8 divided by 107.88 is equal to 0.03974 gram. Transport number of copper plus 2 is loss at anode divided by total ions. 0.0114 divided by 0.03974 is equal to 0.287. Transport number of sulfate is equal to 1 minus 0.287 is equal to 0.713. Next one. Before experiment, 1 gram of anode solution contained 0.001788 gram of AgNO3. After the experiment, 20 gram of anode solution contained 0.06227 gram of AgNO3. In voltameter placed in circuit, 0.0322 gram of silver was deposited. Calculate the transport numbers of Ag plus and NO3 minus ions. Solution. 20 gram of anode solution after electrolysis is equal to 0.06227 gram of AgNO3. 1 gram of anode solution before electrolysis is 0.001788 gram of AgNO3. 20 gram of anode solution is equal to 20 into 0.001788 is equal to 0.03516 gram of AgNO3. Total amount of AgNO3 electrolyzed is equal to amount of Ag deposit into equivalent weight of AgNO3 divided by equivalent weight of Ag. Weight of Ag deposited 0.0322 into 170 divided by 108 is equal to 0.0507 gram of AgNO3. Transport number of Ag plus is Z minus X minus Y divided by Z is equal to 0.0507 minus 0.06227 minus 0.03576 divided by 0.0507 is equal to 0.477. Transport number of nitrate NO3 minus is 1 minus 0.477 is equal to 0.523. Now next one, Kohlrausch Law. To determine with what efficiency the conduction of electricity takes place in an electrolyte, the molar conductivity of an electrolyte when the dilution approaches infinity is often used. When the dilution of an electrolyte is near infinity, it essentially means that the concentration of ions in electrolyte is almost near to zero. In such condition, the electrolyte's molar conductivity is termed as limiting molar conductivity. An important condition for Kohlrausch law is that dilution of the electrolyte must be very near to infinity. This is because as an electrolyte approaches infinite dilution, it completely dissociates into its ions. Therefore, at infinite dilution, an electrolytic solution can be considered to have only ions and non-neutral molecules. Here are some applications of Kohlrausch law. First application is dissociation constant and degree of dissociation. The dissociation constant is a special equilibrium constant that gives a measure of how easily an electrolyte can dissociate into constituents. By using the Kohlrausch law, this constant value can be found out, which in turn can help in understanding of the bonds in an electrolyte. A small constant value implies a stronger bond, while a large constant value implies vice versa. Limiting molar conductivity. Most of the electrolytic solutions in all types of practical usage are near infinite dilution. Therefore, knowledge of their limiting molar conductivity can be useful when used in experiments, batteries, etc. Using Kohlrausch law, finding out the limiting molar. Solubility constant of a salt. Electrolytes usually exist in solid form as a salt. Electrolytic solutions are formed by dissolving these salts in solvent like water. The amount of salt that can be completely dissolved in given amount of solvent is given by the solubility constant of the salt. The higher the solubility constant, the higher the amount of a salt that can be dissolved. Any salt dissolves in a solvent by dissociating it into ions. Therefore, Kohlrausch law is used to identify the degree to which salt can dissociate into ions to dissolve in a solvent. The cell potential of a cells. Cells or batteries have electrolytes in them which produce ions that move to generate electricity. The electricity generated by the battery is limited by the cell potential of the battery. If the electrolytes have higher limiting molar conductivity, their cell potential is higher, which means they can generate a larger amount of electricity. Thank you all.